Okay, so in the previous video, we were able to come up with the recursive solution for my code, and we also understand that yes, this is good recursion, but there's a big problem because this is how the tree for my code looks like. And if we look at the full tree for my code, we are making two choices at every node. And this is going to go in n times, where n is the number of items. So it's going to go in n times deep. So that's one thing to note. And at every node, we are choosing between two choices. So in real sense, the big O notation for my code is going to be 2 to power n, because at every leaf, we have two choices, and we have to go down to a depth of n, which means like if I go to the second depth, the sort of leaves I have or the nodes I have are going to be 4. So you can see that. If I go to the next node, I'm going to have 8, and I'll keep going till the end. So at the end of the day, I'm going to have 2 to power 4 operations. If the number of items available was more, this is 2 to power n. So that's exponential time, not the best for us. We can avoid this exponential time by trying to avoid repeated sub-problems. So how can we avoid repeated sub-problems? In the top-down approach, this means that we go ahead and add memoization to it, such that if we call a function and we had already pre-computed the solution for that particular function, we can call that with no stress whatsoever. So let's come to our code here and let's ask ourselves what this should be for us. Okay, so let's think about this. In the dynamic programming solution, what we usually had is we add a cache, and this we said is a dictionary. And now we have to be slightly creative. What does go to the end dictionary here? So keep in mind, the maximum weight that we are trying to optimize for is very important. Of course, the value of my dictionary is going to be the maximum profit that I'm trying to make. So that's going to be what my function is returning. But at any given instance, I have items and I have the weights. And my function is taking W, which are the weights and the profits. I feel if I include either one of them, it's okay. So probably I can just go ahead and say, probably let me include the weights because these are associative. So if I include the weights, plus the max weight. So I'm going to have a tuple of the max weight and the weights. Probably it's better for me to say these are my weights, and that's the maximum weight available in my knapsack. So that's going to be the tuple that I'm going to have, and the value of my dictionary is going to be this p as well. So that's what I'm going to do here. So let me go ahead and say, before I decide to compute the end thing, I'll be saying if in this sort of tuple, so if this sort of thing, if W and the maximum weight of my knapsack is in my cache.keys, so if that's in my cache.keys, what do we go ahead and do? We go ahead and return what we are getting from my cache.keys. So we go ahead and do this. So this is how I'd go for it. So this is going to be my key. So let's return what we get from that particular key. And in the instance where we don't have that as well, we have to put the solution into the cache. So here, instead of returning AB, I just want to make sure that the value, so when I compute it, I have to save that particular value first. So that is equal to the maximum of A and B. And also in this particular instance as well, I just go ahead and say outside my if statement that cache is equal to, it's going to be equal to that as well. So there I get the cache, and then I return what I get from the cache. And here I get the cache as well, and I also return what I get from the cache. So I'll also return what I get from the cache. Okay, so let's try run our code and see what it gives us here. So if I run my code there, I get a problem here, and it says type error unhashable list. Because we are adding something that is mutable to be the key of the dictionary, that's not acceptable. And W here, which is what you're adding as a key, is mutable. So we need to make it immutable. The best way to make something immutable that's a list is to make it a tuple, which is immutable. So all the places where I have W in my keys, I'm just going to convert it to a tuple using that method for making something a tuple. So every place where I have my key, let me just convert it into a tuple. So here, I make that a tuple. Here as well, I'm working with the key, I make that a tuple. Here, I'm working with the key, I make that a tuple. Here, it should be a tuple as well. And the last instance should be there, it should be a tuple. So now if I run my code with this particular items, I think I'm expecting to get 11. I run that and I'm able to get 11 all through because I've solved the sort of error we have. So this is how I've been able to add memoization to my code so that we can have efficiency and reduce the repeated computations. In the next video, we're now going to switch gears to the bottom-up approach for this problem.